Alright, in this video, we're going to prove the law of cosines. As you can see here, I've chosen one of the standard formula of the law of cosine. And this is here, a squared equals to b squared plus c squared minus 2bc cosine of theta. And that's applied to this angle here. So we can see we're having a here, this is this length here, and the angle theta opposite it. And we have the side c, and we have the length b. To do that, when you have a triangle, you know, this triangle is not right angle. When you have a triangle like this in an air, just like in a 3-dimension, it's not easy to figure out how to define, you know, its length. The easier way is that you can put it on an xy coordinate, and the advantage on it is that the coordinate of two corners of your triangle will be defined. Here we're having the coordinate of this point here is 0, 0, and this point here is c, this length here, and 0 because we don't have any value on the y-axis. And what remains to find is the xy here. We don't have it. Okay, that's what we're gonna do. To do that, to find it, we draw a straight line here to turn this triangle into two right-angled triangles, so that we can use the Pythagorean law. Okay, so we're having this triangle with its side x here. That's what we got here down. We got its values here y, and that's what we got here with the side b and the angle theta. So we're going to find the value of x and y, and that's going to be this point here, okay, by using the Pythagorean's law. Now we're going to use basic trigonometry to find the, you know, the coordinate of this point here. Right, we have this point and this point, we need this point here. Okay, by definition, the cosine of theta here is equals to x over the hypotenuse over b. So we're going to say the cosine of theta equals to x over b. And by multiplying both sides by b, we're going to have x equals to b cosine of theta. So this is the x value of x coordinate of that point. And we also know that by definition that the sine of theta equals to y over hypotenuse over b. And by multiplying both sides with b, we're going to have here y equals to b sine of theta. So this point we're looking for has a coordinate. This is one here, x equals to b cosine of theta, and y equals to b sine of theta. Okay, now that we have all the points of our triangle, we have this point here or the corner, we have this point here, we have that other point here. We now need to find the length of a curve. This is what we're looking for since the very beginning. And we're going to use a strategy, and our strategy is going to be, we're going to write a formula involving a, b, c, and the angle theta. And to do that, we need to use the distance formula, because we need to find this distance here. And the distance formula, which is the distance between 2 points, we're having 1 point here and 2 points here with their coordinate, is going to be the difference of the x values squared plus the difference of the y values squared. And this is going to give us here, if you write it, just put it like this, we're going to say a equals to a big square root of the difference of the x values, difference between the x values of this point here and that point, that would be here, b cosine of theta minus c both squared plus difference between the y values is going to be here b sine of theta minus, and the y value here is 0, and these two also squared. Okay, so now we can, you know, we can distribute or multiply out under the squared. So that's going to give us here, we're having here b squared cosine squared of theta minus, we have bc cosine of theta minus 2bc cosine of theta, and plus c squared plus here, because 0 doesn't mean a thing here, so it's going to remain here, b squared sine squared of theta, and the whole thing under a big square root. Okay, and this is here gonna give us, we can rearrange it, you know, for example, by bringing this b squared here close to that one, so we can, you know, factor out. Okay, that's gonna give us here b squared cosine squared of theta plus, taking this one here, b squared sine squared of theta plus c squared, take a c squared here, and then minus 2 bc cosine of theta. We just rearranging it. Now we can factor out b. We have in here b squared factor, we have in here remaining cosine squared of theta plus here sine squared of theta plus c squared minus 2 bc and the cosine of theta, and the whole thing under a big square. Okay, as you can notice here, cosine squared theta plus sine squared theta is a Pythagorean identity. It's going to be equal to 1, and therefore we're going to have, continue here, the square root of, big square root, so we have here b squared, this is gone, is 1 plus c squared here minus 2 bc and the cosine of theta. So this is here a. Okay, what we need to do now is to square a. If you square it here, we're going to have, therefore, a squared equals to b squared plus c squared minus 2 bc cosine of theta. And this is how we can prove our formula. That's what we were trying to do from the very beginning. Still, you can ever use other sides here. You can use c, you can use b, okay? But the process that I find this is the easiest way to prove it, can apply for any size you're going to use here to try to, to prove the law of cosines. So yeah, of course, this is here our formula. Now the idea here is that if you want to find one of the standard formula of the cosine laws, what you're going to do is to to bring your triangle, or to let it, one of the side be parallel to the x-axis, and that way you're going to have two of the point of the triangle defined, and the only point remaining to be found is going to make things easy. And therefore you're gonna split or cut or divide the triangle into two, yeah, giving you the opportunity of using the basic trigonometry. And this is what we did here, and the basic trigonometry allows us to find the coordinate of this point here, x and y. This is what we got here. And once we have that, we can use a strategy. We could find the length of our, in my case it was a, but it could be c or b, and by writing a formula involving a, b, c, and the angle of theta. So that's what we did here, and using the distance formula, okay, we just wrote here a, the distance between this point and that point here, it's the length a. We're going to use the difference of the x value of the 2 point plus squared plus the difference of the y value of the 2 point. That's what we wrote here, and then we can there distribute or multiply out, okay, through the square root, and then rearrange it here, and rearrange again, and find out that we're having a Pythagorean's identity here, and then we can come to the end result of a equal to the square root of what we got here. So we have in here a equals to the square root of what we got here, b squared plus c squared minus 2bc cosine of theta, and we square both sides of the equality, and it gives us our formula here. And this is the proof of our law of cosine in this case.